Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of representing linear proportional relationships. This is standard 8.5a in the great state of Texas, and we are using item number 14 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So, we have a hot air balloon. It's released at ground level, and it rises into the air at a constant rate. Now, that is going to be extremely helpful for us. So, after 5 seconds, the height of the balloon was at 20 feet, and that wouldn't help us if we didn't have that constant rate, but now we can find a rate of change. And so we've got the balloon that continues to rise at the same rate. And which table, so we're not even going to graph this, we're just going to have a table that's going to look at which table has the best relationship between the time in seconds x and the height of the balloon in feet y. All right, so take a look at what we've got here. We've got 5 seconds. 5 seconds, we say that is 20 feet. And that's the only clue we're going to get. Hopefully this makes us think of our, if we were doing our direct variation, right? We've got that rate right there. And hopefully that's making us think of something we learned last year in 7th grade about how to find our constant of proportionality. And so we just need to figure out what is that constant right there. And so obviously we're just going to divide. What we did here is we just divided both sides by x. That's where that comes from. And so it says that our time is x, and it says our height is y. All right, so let's just look at it that way. So if we look at it 20 over 5, then we are going to simplify that. Let's do it by 5s. And that is going to be 4 over 1, or just 4. So it looks like our k equals 4. So for every 1 second, you get 4 feet, is what it looks like. So that's what we calculated, and let's just see how that works on some of these. Right, so obviously we're just going to kind of do like this. That doesn't work on any of these, but that's what it should be, right? We get our x multiplied by 4, because now we've got our equation of y equals 4x. No, it's just not working on any of them there. Not working on any of these either. So you've got the 25 and the 2.5. So it looks like they're using the same incorrect thinking. Maybe they're just trying to cut this 5 in half. I'm not sure where that 2.5 is coming from or the 25 is coming from. But that doesn't work on that either. All right, here we go. There we go. Look at that, times 4. But that's why you got to look past the first one. See, that's not a times 4. That's not a times 4. Actually, it's just that first one that's a times 4. So let's hope it's J. Yep. 20 times 4 is 80. Yep, let's check mark this. All right, 120. Yep, 4 times 4 is 16, so 40 times 4 is 160. And yeah, there we go. All right, so that's looking good. So honestly, what we just set up is a whole bunch of equivalent fractions. Since we're using the same proportion here, right, we can say 4 over 1 equals, and then we've got this 40 over 10 equals 80 over 20 equals 120 over 30 equals 160 over 40 equals 200 over 50. That's how you can read it, and you see the pattern here. We're going up by 10s and going up by 40s, which reduces to 4, so our answer here is J.